Thanks for coming, and thanks, Sumit, for offering your precious time to visit us. Actually, he is one of us. So he started in Microsoft Research, and of course, we're very proud of what he has achieved. So he started in RISE. He's the main architect of Pendleton and leads which is a data wrangling tool, a data ingestion tool, and he leads the PROSE group that does that. When I read the abstract, he was joking about a midlife crisis, and that's shocking. He's way too young. Rico and I, we can joke about our midlife crisis, but you haven't earned the right yet. You're way too young for that. But anyway, we're really looking forward to your talk.
Okay, thanks, Donald, for the introduction. It's an awesome feeling to be back in my home building here. So my research career has now spanned 18 years. And in the second half of this career, I have led a different research lifestyle than what I had in the first half. And this has given me much more personal satisfaction. And this is a story that I want to share with you today. And unsurprisingly, the story starts with my midlife crisis. So I saved enough to buy my BMW. I had won some ACM awards. I had a decent number of publications, citation counts, H-index, and it was climbing steadily. But then there wasn't... but some form of deeper meaning was lacking. The work that I was doing, I felt, was not as much significant for the society and the legacy that it would possibly leave. And this inspired me to start looking for fixing this situation. Right? And the idea was clear. I wanted to transition to different value systems. Now, by no means these value systems are novel. In fact, they are very simple. But the reason why I'm excited to talk about them today is that they are unreasonably effective. In fact, many of you might actually already be following these kinds of value systems. However, I have to admit that the academic world, of which we are all products of, does not emphasize these value systems as much as it should. The reason why I call them big bets is because that the transition to these value systems was not easy, because change is usually hard. And I was very intentional about making this switch. And this is something that required a huge amount of effort, which makes up for an interesting story to be shared. However, the most important thing here is that these were just not my bets. I did not simply bet on these value systems, but I also bet on the people who are involved with this transition. This was the bet that even those people made. This was the bet that was even made by the people who funded these arrangements. So this is a story of several of us together. So before I describe these 4 bets, let me actually provide some context in terms of the research agenda that I was working on, and I would explain these bets in that specific context. So the problem that had taken most of my interest was this of program synthesis. The goal here is to automatically search for a program in an underlying domain-specific language from some natural form of intent provided by the user, either in the form of input-output examples or natural language. And in fact, this had been an old problem, almost as old as programming, but not much success was achieved back then. But in the past decade, we have seen some significant advances in this area, thanks to much better algorithms and faster machines. In fact, just to boast what we have achieved now, a few months ago, we conducted an experiment with some Python programmers. We gave them a data cleaning task, and they took on average 30 minutes to finish this task. We can do the same task using our program synthesis APIs in 30 seconds. So program synthesis can really improve the productivity of developers by 1 to 2 orders of magnitude in certain task domains. But what gets me even more excited is the potential that it can enable non-programmers to create small scripts for automating repetitive tasks. 99% people who have computers do not know programming. And these people struggle with repetitive tasks in their lives. But these are not stupid people. They just don't know the artificial programming language of speaking to a computer. But program synthesis technologies can enable these people to achieve much more in their lives now, because they can use computers much more effectively. So this is the context of the research that I was in. And when I had this midlife crisis, I was working on program synthesis for trying to help algorithm designers and hardcore software developers. And the kinds of tasks that we were looking at was to synthesize textbook algorithms like sorting algorithms, or to synthesize tricky pieces of code that even humans would take years or two to come up with. And this had to change. So the first bet that I placed was to be able to connect to the customers more directly, because this kind of program synthesis was not able to achieve the kind of dream that I just outlined earlier, to be able to help developers in their regular tasks, or to be able to help non-programmers with the tasks that they struggle with. So in this old world, the way I would choose the problem that I would go solve would be mostly inspired by what will help me publish a paper in a top-tier conference. What is the next incremental or foundational improvement that I can do which can get me a next paper in a top-tier research conference? And the way I would define my success metrics would be to either come up with a benchmark myself. In fact, I have written papers which just get cited by the benchmarks that I chose there, and those benchmarks were just made up from some imagination one afternoon. And the other way I would choose the benchmarks would be to just follow what other people would use in their papers. And this is the stuff that had to change if I really wanted to connect with real people and change their lives. So in this new world, I found a lot of inspiration from help forums by trying to understand what were the pain points of different users. In fact, more recently, we have been conducting exercises like Moneyball, where for 6 weeks we do nothing but just try to connect to customers. We write scripts to figure out contact information of customers from different social networking sites. We email them to try to set up a phone call. If phone call looks promising, we invite them to a workshop at Microsoft. After running that workshop, we figure out what did not work well, and we repeat the process for the other 3 weeks. In fact, when we do our releases, we are very cognizant of putting in proper telemetry and be able to get feedback from users. So this is the world that I wanted to be in. And the transition point came. So there's a small incident that I'd like to share here. So I was coming back in an airplane after presenting some program synthesis innovations at a workshop. And there was a lady sitting next to me. And she was very impressed to know that I worked for Microsoft and that I had a PhD. So she thought I better ought to be able to help her with the Excel task that she was struggling with. She opened up her machine and asked me how she can do one transformation on her column. And at that time, I had to excuse myself out of the situation because I did not have any knowledge about the programming model inside Excel. But that gave me a hint that these are the kinds of simple tasks that I need to, or I should consider going after, as opposed to trying to come up with tricky bit vector algorithms or reinvent sorting algorithms which have been known for ages, because that research is not going to help anyone. So I spent months trying to study spreadsheet help forums to figure out what problem should I be solving, which simplest problem can yield the biggest benefit, and what should be the initial target benchmarks that I should be working with. This was a typical interaction that I noticed on a help forum. An end user would ask an expert on the help forum, can you please give me a script or a program that can convert the string on the left side of this arrow to the string on the right side of this arrow? The expert would look at this input-output example and will provide a script that would say extract 2 characters starting at the 5th character. Now the end user will take this program and figure out that it doesn't do the right job at this other input. The expert looks at it again and probably tries to have a better model of the intent that the user has. So what do you think is the end user trying to do here?
Tokenize and extract.
Yes, so extract everything that is between the first 2 underscores. And do you know how would you program this in Excel? So Excel has a programming model, and this is one of the simplest programs that you can write. So even if you know programming, you'll have to go to Stack Overflow or some kind of documentation to figure out what is the API that Excel exposes. But you are the lucky one, the 1% people who know programming. Think about 99% people who do not know programming. They will be stuck. Right? Now in this case, the end user takes this script and runs it and sends a thank you to the expert. And this is the feature that we designed, which shipped in Excel in 2013 and received quite a good reception. So it also led me publishing this particular paper. So this is one of the 100+ papers that I have published in my career. Most of those papers have the similar kind of intellectual depth, but this is the work that I am most known for. So why do you think this is the case? This is because not only this work appeared in a top-tier conference, but this work also solves a problem that real people care about, that shipped in Excel. And this is something that I would say does not happen that often. It is very easy to do one of the two. Write software that is used by millions of people. Everyone in office does that. Or write a research paper, and all researchers do that. But the intersection is one which is really makes this paper special. Now, several people often comment that, oh, Sumit got lucky because he worked at Microsoft. So he figured out the problem from there, and the Excel team gave him the benchmarks. The truth is, even the Excel team was inspired from us looking at help forums to figure out what a target benchmark should be. They didn't really give us much benchmark. They didn't really help us much in terms of benchmarks. And the way I went about identifying the problem definition and figuring out the benchmark is something that any academic could have possibly done themselves as well. They didn't need to be inside Microsoft to do that. The question really is, would they be willing to spend 3 months doing nothing, just looking at help forums? And that is what this change was all about. That is the risk, the bet that I took in my career, which I think paid off quite well. Actually, there's a funny story behind how we got this paper accepted. So a few days before I was about to submit this paper to this conference, I started going through the email where I had accepted the invitation to be on the PC for this conference to just see how strict their standards would be for PC submissions. And then I realized it said single authored submissions from PC members not allowed. And then I sent a mail to the chair saying, I believe this is the most important paper in my life that I have written about until now. And I happen to have agreed to this weird requirement that you have. Do you want me to include my wife's name on the paper? And then within a few hours, an email gets sent out to all the PC members saying, I want to lift this requirement unless someone has an objection. And that paved the way for me to submit this paper. And this really changed how I started conducting research after this point onwards. After we got addicted to this kind of success, we wanted to now apply this kind of programming by examples to many new different domains. So instead of just doing string transformations, we applied it to doing number transformations, for instance. Even a task as simple as rounding a number to 2 decimal places requires you to remember different kinds of format descriptors in different languages. But again, examples are a very natural way to specify intent here. Or maybe think of a task which is a bit more involved, and you'll have to spend several minutes trying to think of a script to do this conversion. But again, these are the kinds of tasks that now we can do with a few examples. We applied it to the domain of extracting tabular data from log files. This is an assignment taken from a data science class where the instructor asks the students to extract the tabular data that you see on the right side, and the instructor gives them a script to start with. So the goal is to take this script and build on it to go from left to right. But the experience we designed, all that the user has to do is to give an example of two of the various fields that they want to extract, and then we'll automatically be able to extract other instances of that field. We applied it to manipulating semi-structured spreadsheets. It turns out 50% Excel spreadsheets are semi-structured, and the task of going from the left to the right is usually quite involved. But again, this can be facilitated by simply a few examples. So this application domain that I mentioned to you can be clubbed under what is called data transformations or data wrangling. And this is where data scientists apparently spend 80% of their time before they can bring data into a form where they can apply machine learning to in order to be able to build interesting models. Another killer application is code transformations. If you want to help users or developers migrate their code from one platform to another one, from an old version of a framework to a new version of their framework, in such migration scenarios, they are apparently spending 40% of their time doing repetitive code edits. But again, this is a scenario where they can give one or two examples of the edits they want, and the system can automatically suggest them all other places where they might want to do such transformations. So a huge range of applications, basically. This is the thing that I wanted to really emphasize here. But how did all of this actually come about? Right? Even starting with the fact that I told you that this purple paper that I wrote on flash fill, I spent 3 months just studying the help forums, and only 3 weeks coming up with an algorithm and implementing it, and maybe a couple of other weeks writing the draft of the paper. But then it took 2 years to ship this product with Excel, and it was no mean feat. The first support that I got was from my manager at that time, Benzon, who played the perfect selfless role of ensuring that this technology actually meets its right fate. It was very hard for me to even connect to the right set of people in Excel in order to be able to show them this technology. But Ben had the right set of contacts, and he facilitated that. We had an RSD who devoted himself for 1 or 2 years in order to be able to do this tech transfer with Excel. We had a PM, Shobna Balakrishnan, who played the right role in dealing with the upper management as well as the people on the ground in order to get this technology shipped out. I think the star of the show has to be Rishabh Singh, who came here for 3 different internships. And when his OPT finally ran out, we shipped him to India so that he can work for us from there. He took this technology to a completely new level. There were many interns who followed, who worked on these different variations that I talked about, like extracting data from log files, extracting tabular data from semi-structured spreadsheets. Gustavo, who worked on doing code transformations from examples. Mark, who is in the room here, who led work on programming by natural language. There's one important character missing on this slide. Who would you guess what the role of that character would be? So I'm talking about my partners here, right? So
Your wife. Your wife.
She was a cause.
3 internships, 2 internships, a contractor position, 2-year postdoc, almost like another 1 year of funding. Where does this funding come from? So this is the funding god, who enabled this arrangement. So Rico was running this Impossible Things initiative at that time. And he took bet on this technology so that it can actually see where it ought to be. So now we invested into so many different kinds of task domains for program synthesis. But there was one big challenge, that developing each of these program synthesizers was a very tedious effort. It required you to think of an algorithm from the beginning. It required you to do an implementation. And if you want to do a robust implementation, you had to spend months engineering it. And also people in academia started rumors that, oh, Sumit is now only doing practical research. So it was not time for payback. And all the environment was well set up for the second bet which was to develop a framework that can facilitate the design and development of these kinds of program synthesizers for various individual domains. So in the old world, we would invent a program synthesis algorithm for scratch for a new domain. And we had worked on 20 such domains. And each of them would be publishable in a top-tier conference. And we can keep continuing the crank there. But we wanted to do something better. So we wanted to develop a framework that would be parameterized by various domain-specific concepts so that it can guide our algorithmic thinking. It can make the time to engineer a robust synthesizer from months to a few weeks. And furthermore, this will also pave way for doing new research. But now the new research that will be done will actually provide value for all different domains as opposed to being domain-specific. So this is how the framework actually looks like. So in the old world, you would have a synthesizer for each domain, which will take as input examples and will output a program. And this is what the model inside FlashFill is. But the first kind of parameterization that we did here was that instead of having the search algorithm be very domain-specific and having a separate search algorithm for each different domain, we parameterized this search algorithm with the underlying domain-specific language in which we wanted to synthesize programs. So now to develop a synthesizer for a different domain, you can plug in a separate domain-specific language. Another interesting point here is that examples are a very ambiguous form of user's intent. When you give me one or two examples, the number of programs in my domain-specific language that match those examples is often 10 to the power 50. So we need to pick a program that we believe matches the user's intent. And if we don't get this right, Excel will not ship FlashFill. In fact, they demanded that for most simple tasks, we ought to read the mind of the user from just one input-output example, because otherwise people would lose trust in this technology. They would not use it. They will come up with funny interpretations. And the ranking algorithm that we used was intertwined with the search algorithm. But this was a good opportunity to separate the two things together. So now the search algorithm returns a program set, the set of all programs that match the examples. And now we have a separate ranker which can take the program set and produce a rank program set. And furthermore, this ranker can be parameterized by different kinds of ranking functions or features. We can also build interactivity in this loop. We can actually guide the user in deciding if they need to provide us more examples or not. And once we believe that they might have a correct program, we can show them the program in our domain-specific language, which can then be translated to any language of choice, like Python, R, C# or Java. So this is what the overall structure or architecture looks like. But how did we get here?
Yeah. So for the user input, you are exposing it to the user in the domain-specific language, right? And the other motivation you had is a user who doesn't know programming, right?
Yes. So good question, right? So the end user only interacts with the red color here.
Okay.
The blue color is done by researchers or advanced developers like us.
Okay.
Yes. So Wu Li had developed this system called FlashExtract, which would extract tabular data from log files. And we wanted to also extend this work to be able to extract data from web pages, extract data from semi-structured documents. And then he ended up doing another implementation of FlashExtract for log files so that it becomes general enough that we can also use the same framework to extract data from web pages, from spreadsheets. And this resulted in some kind of generalization and a step towards this framework. We had another intern, Dilip Kini, who worked on extending FlashFill to doing much more complicated tasks. So he experimented with new interaction models. He experimented with new synthesis techniques. And I would say it was a mild success. It resulted in a paper, but did not make as much dent as we had hoped for. But these were kind of fine steps, two fine steps towards the process. Around the same time, I had an intern, Alex Polozov, who is actually in the room, who was being randomized by me on many different kinds of projects, and he was watching this thing happening from the sidelines. And then he came to me and he said, Sumit, I can solve the problem that you're really looking to solve here. But he was not clear whether he would want to solve it or not, and how would this actually work out, because he was a student at UW, and solving this problem really required a big dedication. I convinced him several weeks, and then finally he decided that he will actually be doing his PhD at Microsoft Research, working full-time on this particular project. And so he did. He actually solved this problem. And I think this is a beautiful paper that he authored. But while he was focused on developing the nuts and bolts of the framework, we required Wu to re-implement FlashExtract yet another time. Right? So first he implemented FlashExtract for log files. Actually, that was a second implementation of FlashExtract for log files, because there was one other person, Herman Venter, who had developed the first implementation, but unfortunately he left the company after a year. Then Wu developed FlashExtract the second time. Wu implemented FlashExtract the third time so that we can generalize it not just to log files, but to other formats. And then he provided great service to Alex by re-implementing FlashExtract in the most general framework that we now have. So 4 times implementation of FlashExtract. And not only that, other interns who were also around or who could participate tried to re-implement what they had done in the framework that Alex proposed. So just imagine the amount of investment that is going into this. Implementing FlashExtract the 4th time. What business value is that adding? Right? And who on earth would fund that effort? Rico, I gave you a lot of, probably too much credit last time when I said that you funded FlashFill and FlashExtract, because any sane person, would want to throw money at that. Right? It's so cool, just looks so cool from this concept. But who would put money on this? This is the real credit that actually Rico gets. Right? Again, months of internship, paying for the stipend of Alex for the entire year, paying his tuition, is quite expensive. But this is the place where Rico really put his foot forward. And I'm not sure if he trusted, he put a bet on the project, but probably he also put a bet on me. Right? So it was his bet on both the technology as well as people. Now, what was the next problem here? So I have to tell you folks, Alex is a talent. Right? He is one of the best engineers that I have known, and he could deal with the sophisticated theory that is there inside this paper. It's hard to find gems like him. Absolutely hard. Right? I cannot, just manufacture new Alexes and put them together. And also, he needs to be left alone to decide his own, paths and directions in life. So how can I carry forward this mission where I really need to take this framework and make it production quality? If we just continue to depend upon interns, this is not going to work out, because interns are going to leave. They can come for 3 internships. They can again extend their contract for another 6 months. We can continue to get angel funding from Rico, but this model is not going to sustain. So something has to really change. And this brings me to the third bet, which is about my belief of putting research and engineering together. So if you recall, the success of FlashFill relied on 2 years of engagement with the Excel team, where we had built a research prototype and the Excel team took it and copied it line by line into C++. So our C# code was copied line by line into C++. And if they had any issues, performance issues, or some bugs that they needed to fix, they would get back to us, we would fix it in our code, and then they would take it. But we want to do more such things, and we want to accelerate them, right? So using this model of what we call tech transfer is not going to work here. We have to build and deliver the tech ourselves. Also,
So, did you consider the option to open source and therefore get more traction that way for the software that you were building?
So that's an interesting question, and my feel is that the time is still not right before we get there, because we are still in the early stages. I think the project needs to be matured up to a certain level. When open sourcing it will start adding value. Also, my role up until now was more of an individual contributor. Right? Of course, I was working with many collaborators. I was involved with 20 projects in a year, and in 1 year, I was working with a total of 50 people on those 20 projects. So I was not alone. But I was still what I will call an individual contributor. I was splitting my time into multiple projects, spending 5% of my time on this project, 10% of my time on this project, and these were all disparate projects or maybe loosely connected. But what we needed was a team which will have a shared mission and which will actually work together. So I sometimes joke and explain my situation, this past situation of individual contributor as I was having multiple girlfriends at the same time, which was, of course, a very thrilling situation. But now with a team, it is like being settled in a family, right? Where everyone has the same mission and working towards the same thing. And another thing that got me quite inspired from one of Peter Lee's slides on different quadrants is the appreciation of two different styles of research, one of which he called long-term blue sky research, and the other thing was short-term mission focused. And I used to think that at some point of time, I need to be in one of those quadrants. But this is the assumption that I started challenging. And now what I believe is that we ought to fund blue sky research by using mission-focused deliverables, and we need to find synergies between these two goals. So how would this research and engineering be put together? So here is a slide that I have which tries to capture some of my thoughts here. So first, I noticed that there is quite a parallelism between the research word and the engineering word. And both those words have appreciation for long-term processes as well as short-term value proposition that they offer. So work like Flashfill would actually fit in this bucket, where our goal is to work on the next shiny thing, write a research paper, make a quick impact. Right? The work on Flash Meta, this is the framework that Alex built, will fall in this bucket here. And normally what we would do is we will do multiple instantiations first, like FlashFill, FlashExtract, FlashNormalize, FlashRelate, and we'll then try to generalize them into a framework. This is the old word. This is the old typical academic word. But now for a change, what if we productize the framework and then we start building innovation on top of that framework? And this is the new word, which will speed up innovation. Also, by trying to do something cool and then trying to figure out what kind of consumers or customers can have impact, or in which product can I put my technology, that's a very fine way of doing things. But I think in the new world, what I would like to do things is completely the other way around, where I would first like to connect with customers and try to understand what are some of the relevant problems so that I don't waste my time trying to solve problems which are not as relevant. And both problems are equally intellectually interesting, right? But if I have a choice, I would rather pick something that is more relevant. And furthermore, if I set up my engineering processes right, then all of these three quadrants are going to actually have a push onto innovation. So even if I end up spending a fraction of my time in this quadrant, the fact that I have invested here in these other quadrants is actually going to push and accelerate the development of new ideas and their delivery. So this is what we also see, with the interns that we sometimes get. So I've had experience where if I get a very smart student but who is not that great at engineering, they actually sometimes struggle because with the limited time that they have, they are able to try out only few ideas. But someone who is probably not as good but a much strong engineer is sometimes more successful because they are able to try out many more ideas in the same amount of time. So this is the kind of structure that I wanted, where engineers and researchers would be working synergistically. And this is the team that I now have, where the goal of researchers is not to develop prototypes and throw it to engineers for them to productize. No, researchers have to do product quality implementation of their ideas. But I do acknowledge the fact that not everyone is like Alex. People are not trained to be great software engineers, But as long as the engineers on the team are willing to give the researchers guidance on how to do right software engineering, and as long as the researchers are open to picking up on it, it will work out. And this is the arrangement that I have on my team right now. And furthermore, it's teamwork. So while every researcher on the team has the ownership of some important capability, all these capabilities are coming together towards a common mission. It's not like everyone is trying to create their own islands of excellence. So as a research manager, my responsibility is to make sure that every researcher in the team shines with whatever they do, but it also all coherently fits together as part of one single big mission. So many people think that I'm running a product team or an engineering team. This is completely not true. I'm running as strong a research team as you might find inside this building. The only reason why I moved out was because I did not want to be a burden on MSR or more of a drain on MSR. I wanted to leave the angel investors like Rico free to fund new entrepreneurs like Sumit. This is the kind of model which I believe is more sustainable. This is the message that I want to spread around, that product groups should fund research not just as a philanthropic activity, but it can really increase their business. It can really bring them distinguished value to their business. And if we start thinking like this, there's a huge amount of money in this world, outside of this small little organization that we live in. And it is inside this outside world that we should be seeking real funding that goes beyond angel investing. So this is a message that I really want to share here. So now the final bet. And this is about my belief in cross-disciplinary research. The initial bug actually hit me when I was working with Nibosh, who was part of the reason why I even joined Microsoft Research Edmond in the first place, because we saw potential of applying machine learning for program synthesis. But sorry, Nibosh, I didn't follow up too much on that after our initial project. But more recently, this has come to be very true. So cross-disciplinary research is hard for many reasons. It is difficult to explain to the other community that you have done something meaningful. It is difficult to receive funding in that thing. You're not really an expert in that area. So what do you typically do? Right? You might just ignore it. You can ignore it for various reasons. One reason you might ignore it is that you really believe that your community has the right tools and techniques to take a stab at that problem. Or you might ignore it because you simply don't care. It's like an ostrich hiding its head inside the sand. Or the other option that you have is to remain in awe of the other kind of technology. And the change that I'm now imbibing in my new word is the belief that the third wave of AI will actually combine the techniques from my area, which is that of formal methods, logical reasoning techniques, and from that of the machine learning community, all the statistical learning that is there. But how would I go about doing this cross-disciplinary research? I'm not an expert in this area. I really need to find the right empathetic expert who is willing to be a partner. Because simple collaborations for the sake of writing a paper are not going to help and push this thing much further. So let me actually explain to you what are the opportunities for why I believe that combining logic and machine learning is quite important for creating many different kinds of AI software. So here is some intelligent piece of some software that behaves intelligently. And three instances of such pieces would be the three components that I showed you in this framework for program synthesis. One was the search algorithm, the ranking algorithm, and the disambiguation algorithm. So such an intelligent component is often composed of two different pieces: logical strategies or algorithms that we understand very well, and something that I would like to call creative heuristics. If I further drill down into the creative heuristics, at least in our code base, we find that it is made up of various kinds of features and some weights over those features. For instance, there's a constant 0.8 being used in my code base. So I asked the researcher, why did you use 0.8? The answer is, it just seems to work well. But in the new world, it would be fantastic if developers or researchers focus their time on identifying the right features and writing what is a well understood knowledge, and leave the model building exercise to a machine learning backed runtime. This can help us come up with not only better models and make us more effective, but it can also lead to these systems being adaptive and personalized. So just imagine, when FlashFill is running on different users' machines, if a user is dealing with the same kind of data over and over again, then instead of having to give 2 or 3 examples, the system can understand their intent from just 1 example. In some cases, even 0.1 examples or 0 examples. Right? And I can formalize that. Maybe if you're interested, you can talk to me after the talk. So this kind of adaptivity would be possible only if we are using some automated way to fine-tune the creative heuristics or the ranking strategies that are inside underneath the software. So this kind of division would facilitate that. So I can go a little bit more into this detail for each of the 3 components that I showed you in the program synthesis framework. So if you recall, there was a search algorithm that was parameterized by a domain-specific language. And the domain-specific language is usually specified as some rules in a grammar. And we have a fancy search strategy that we use to explore that grammar in order to figure out the program that satisfies the user's intent. There are lots of heuristics that we use actually in order to make this process scalable and robust. Which grammar production to try first or to not try? Which disjunctive, which subgoal from a disjunction of subgoals to explore when we are trying to make our progress towards the goal? And each of these decisions can actually be learned from large amounts of data that we have, and if we use the right machine learning modeling and learning there. Here is another example of program ranking. So we have many programs that match the user's input-output examples, but we need to choose one of those programs. So we need to have techniques that can rank different programs. And this ranking is based upon syntactic features of the program, or even features of the outputs produced by 2 or 3 different programs on a given set of inputs. Now, what weights do you use for these different features? And this is again something that can be learned from machine learning. In fact, some features are more machine learning than logical, like is this string the name of a person? And in the disambiguation box that I showed you, we need to communicate some actionable information to the user so that the user can decide if they need to provide more examples or are they done. We can show users some corner cases where they need to provide more examples. But there are many heuristics that are used inside this process that can be machine learned. For instance, when to stop asking questions. So every question comes up with some kind of probability or threshold, and if it is above that threshold, we present it to the user. But what is that threshold? Or if we want to cluster the inputs based upon their syntactic structure, this is again where machine learning techniques can be quite useful. So in order for us to make big advances in this area, my partner in crime has been Prateek Jain, who is a world-renowned machine learning expert at MSRI. And he received great support from other colleagues at the lab. And then he also brought in a lot of resourcing in the form of interns and research fellows. And this is what it takes to start experimenting with such cross-disciplinary research in a serious way. And again, all of this arrangement was facilitated by Sriram Rajamani, who is the lab director, who wanted to bet on this direction of research. So I'll conclude now. So I talked to you about these 4 big bets that have brought in lot of value, but there are also new challenges that have come in, and I'll just summarize those here. So when you talk about connecting with customers and gathering real data, or maybe in the form of telemetry or figuring out where my AI solution is not working well so that I can improve my AI offering, we are going to have new challenges with respect to collecting data because of the GDPR requirements. So an interesting research problem that this opens up is how can you get data back without violating any of the privacy issues that can yield you enough information that you can innovate on your service. And we already actually have a lot of real customer data, and we want to release it in service of the academic community and for other competitors to try out newer ideas. But the problem is, the damn problem is that the data is so real that we just cannot release it. It is the opposite problem now. So we're not trying to see if we can fake up this data so that the real challenges of synthesis are still preserved, but the data is completely faked up, and then we can release this data. The other thing that I talked about was taking a framework-based approach to designing and development. And one challenge that of course always remains is how to balance between specialization and generalization. Because with a fixed amount of funding, resources, time, either you can structure something that is very intelligent for a vertical domain, or you can do something that is less intelligent for a more general purpose layer. So we always have to make the right set of choices there. It's not easy. The third bet I talked about was putting research and engineering together. And here it even involves doing an end-to-end delivery of your offering. What about maintenance? You put this thing out, and then are you committing to maintaining it indefinitely? And even people management is an interesting unspoken aspect here when you're running a big team of people working together. And then the final thing that I talked about was the significance of cross-disciplinary research. And one challenge that comes here is how do you balance between doing some quick experiments versus doing things in a way so that you're already always production ready.